Hello everyone, I'm back with another videos related to CSIR UGC net solved questions. Today we are going to solve some of the matrices related questions. Today we are going to see another important topic in matrix, that is eigenvalues. So the eigenvalues of the matrix can be determined in two different ways. The first method is, we can write it as solution 1, as there are three rows, so this eigenvector will have three eigenvalues. Lambda 1, lambda 2 and lambda 3 will be the eigenvalues for this matrix because of three non-zero rows present in it. So we know that, let me consider this matrix as, A is equal to matrix 1 0 0 0 1 1 and 0 1 1. So there is simple rules in matrices, like the product of eigenvalues. Here, as there are three eigenvalues, so lambda 1, lambda 2, lambda 3 should always be equal to the determinant of the matrix, and the sum of the eigenvalues will be equal to trace of the matrix. So trace of matrix means, trace of A means sum of diagonal elements. So here first I am finding what is determinant of A. Determinant of A is 1 0 0 0 1 1 and 0 1 1. So the determinant will be 1. Ignore the first row and first column. 1 into 1 1 minus 1, and the other terms will be 0. So determinant of A is 0. Now if I find trace of A, sum of the diagonal, that is 1 plus, diagonal elements are 1 plus 1 plus 1. So the trace of the matrix is 3. So it is obtained like lambda 1 dot lambda 2 into lambda 3 is 0, while lambda 1 plus lambda 2 plus lambda 3 is 3. So if we assume from the product, we can get that, suppose if I bring lambda 2 and lambda 3 this side, so lambda 1 is equal to 0. Now if I substitute lambda 1 is equal to 0 here, so 0 plus lambda 2 plus lambda 3 is equal to 3. So what are the two values which will give me the whose sum will give me the answer as 3? It should be positive numbers in most of the cases, assume it. So it can be 1 and 2 only, because 1 plus 2 is 3. So the lambda 1 value is 0, lambda 2 value is 1 and lambda 3 value is 2. This is one of the way to find the eigenvalues. The other way, the second method to determine the eigenvalue of the matrix is by using the characteristic equation. So I am writing it as solution 2, and I am denoting this matrix as A. So the characteristic equation is found by doing A minus lambda I first. So A matrix is 1. Okay, I have to write it more big. 1 0 0 0 1 1 0 1 1 minus lambda into I is nothing but identity matrix, so 1 0 0 0 1 0 and 0 0 1. So if I multiply this lambda here, it will become 1 0 0 0 1 1 0 1 1 minus lambda 0 0 0 lambda 0 0 0 lambda. Now I can subtract these two. So what I'll get is matrix A minus lambda I is nothing but 1 minus lambda 0 0 0 0 1 minus lambda 1 again 0 1 1 minus lambda. So to determine the characteristic equation or to find the characteristic equation, what we have to do is we have to find the determinant of this matrix A minus lambda I and equate it with 0. So determinant of 1 minus lambda 0 0 0 1 minus lambda 1 and then again the value is 0 1 1 minus lambda, that is equal to 0. So on substituting, on finding the determinant, it will be 1 minus lambda. Ignore the first row and first column, so it will be 1 minus lambda the whole square minus of 1, that is equal to 0. So if I solve it, it is 1 minus lambda a minus b the whole square form it is, so it will be a square, that is 1, plus b square, that is lambda square, minus 2ab, so 2 lambda minus 1 equal to 0. Now this one and this one will get cancelled. 1 minus 1, it will become 0. So 1, okay. So 1 minus lambda into lambda square minus 2 lambda is equal to 0. I can take this lambda out. So what will get? Lambda into 1 minus lambda into lambda minus 2 equal to 0. So there are 3 factors here. So the roots for these factors will be, let me say, lambda 1 equal to 0. 1 minus lambda, I can equate it to 0. 1 minus lambda is equal to 0. So lambda 2 will be 1. Similarly, lambda 3 minus 2 can be equated to 0. So lambda 3 will be equal to 2. So in this way, again, we can find the eigenvalues, that is 0, 1 and 2. In the next question, the matrix is given in terms of complex or trigonometric functions. Like these functions, if they give, it is better to go for characteristic equation method alone. So here I am again doing it. So I am directly skipping to the characteristic equation part, lambda minus, determinant of A minus lambda I. So it will be cos theta minus lambda minus sin theta, then sin theta and cos theta minus lambda. So determinant, we have to find cos theta minus lambda square, cos theta minus lambda square, and then minus of minus plus sine square theta, and this is equated with 0. So a minus b the whole square form, that is cos square theta plus lambda square minus 2 lambda cos theta plus sine square theta is equal to 0. Cos square theta plus sine square theta will become 1 plus lambda square minus 2 lambda cos theta is equal to 0. So it is in the form of lambda square minus 2 lambda cos theta plus 1 is equal to 0. So I can, so the root of that equation, that is lambda square, okay, just a minute, lambda square minus 2 lambda cos theta plus 1 is equal to 0 can be found with the formula b minus b plus or minus root of b square plus 4ac, sorry, minus 4ac by 2a using this formula. So here a is 1 from the above equation. A is 1, b is 2 cos theta, and c is again 1. So lambda will be minus of minus 2 lambda, so plus 2 cos theta plus or minus root of 4 cos square theta minus 4 into a into c, that is 4, divided by 2 into a, that is 2. So it can be simplified as 2 cos theta plus or minus 4 is common, I can take it out as 2 root of cos square theta minus 1 divided by 2. So cos square theta minus 1 is nothing but sin square theta. So 2 cos theta plus or minus 2 sin theta divided by 2. So 2 can be taken out and cancelled, and it can be written as cos theta plus or minus sin theta. This gives the lambda value as e power I plus or minus I theta is the eigenvalue. Because if we expand this, we will get this answer. So this is the eigenvalue. Okay. Thank you.